Today it's called Applications of Sequences. Is it any different? Not much. It's just word problems where you have to figure out what the equation is and then put it in your calculator to solve them. What we did yesterday was learned how to get a starting number that isn't always 1. Sometimes it's 0. And then we would do this part with a 1 plus 0.05, for example. And that means 5% what? Growth. What if this had been a minus 0.05? 5% decay. And then, if it was 5% decay, what is the common ratio? You actually subtract them then, and you say 0.95. The common ratio is 0.95. The growth rate, in this case the decay rate, was 5%. Okay, let's just see if you really caught that. You should be able to tell me what all this means. U sub n minus 1, and then 0.85. I'm making your life kind of difficult by doing it this way. I want to know what is the common ratio and what is the growth or decay rate. I'm going to pause for a second while you think about what you learned yesterday. Common ratio is 0.85. I think it's smarter to write it like this, 1 minus 0.15. But the common ratio is 0.85. If you had written this, I would have accepted it for the common ratio. Then, is that growth or decay? Decay, and the rate of decay, 15%. If you put 0.15, you could lose points. If they ask for a percent, you should say 15%. All right. So now, one of the things that we're going to do is get a little more technical with you. Like, you know, the numbers aren't as nice as 85 anymore. What if it's u sub n minus 1, and this is 0.808? What in the heck would that mean? Well, what's the common ratio? That's simple. 0.808. But what's the growth or decay? First of all, is it growth or decay? Decay. All you got to really do is take 1 minus that, and you'll figure out that it's actually 1 minus what is equal to 0.808. 192? And what does that mean? 19.2% decay. All right, so sometimes we step up the decimals a little bit. And then another thing we do today is we don't always start with u sub 0 or u sub 1. What if this is a population of Minnetonka? We have a population of around 55,000 here in Minnetonka. Minnetonka is a pretty big place. We actually have, you know, like it's our school district covers a whole bunch of different areas, part of Eden Prairie, part of Chaska, no, part of Chanhassen, etc. But the actual Minnetonka city runs all the way in, and Hopkins has a lot of the city of Minnetonka in it. And so anyway, it's kind of weird. You'd think Minnetonka schools would be in just Minnetonka, but it's not that simple. Anyway, but if you look it up, Minnetonka's population is around 55,000. Do you think that we're growing or shrinking? Pretty much holding steady or growing a little bit. Okay. It's not like Detroit. What do you think's happening there? It's been shrinking a lot. And there's other cities that are shrinking. There's other cities that are growing a lot. The most popular place to move is out to the west coast, especially the upper north area there, like Washington, Portland, you know, Seattle kind of area. Yeah, that's been a really popular place to move. So their areas are growing like crazy. Okay, anyway, we'll be doing problems like this, and we'll say, okay, the current year is 2018. You can say u sub 2018. Now, why would you want to do that? Because then when you look at your table, you know how your table would normally have said 1, 2, 3, and then it was 55,000, and let's say it's growing. If it's really going to grow, I better put a growth rate here. Let's say it's 1 plus 0.02. That's growing by 2%, okay? And then my 55,000 grows a little bit. Let me see if I can do it in my head. 1% would be 550. So 2% would be 1,100. So this would be 56,100. I think I did that right in my head. Anyway, but it would be nicer if it just had the year next to it instead of a 1, 2, and a 3. So if you start with this, it'll say 2018 on your table. It's really kind of cool. And then the next year, it'll know 2019. And see how it's easier to read it then? All right, one technicality then that is difficult is you go to your table and people are like, why isn't this showing up? What little thing do you have to do because you're going to use these huge 2018 sub numbers? What do you have to do with your table? Yes?
You have to do second table set.
Table settings. Yes, you need to go to your table settings and move them up to the year you're at. Otherwise, your table's trying to tell you where 1, 2, 3 are. You know what I mean? Your table doesn't know yet that you've changed it to this. It'd be really cool if it was smart enough to go, I know you're starting in 2018 and I will automatically adjust my table accordingly, but it's not that smart. So you got to go to your table settings and say, I want to see the 2018th line of the table. All right. I would like you to actually put this in right now. Put this one into your calculator right now. And if you've learned how to put that in, I hope you know that the very first line, the top line, will be the number I heavily circled there. The first line of your equation will ask n min. Our n min is 2018. I'll pause for a second while you get that in. Okay, so I got it all in there properly, and I hit table, and this is where mine went. Something feels wrong. Well, I didn't have my table set to start at 2018. Mine's starting at 2040. But it's actually primed pretty well to answer this question. When will Minnetonka's population cross over 100,000? You see on mine? Well, maybe you need to arrow down a bunch of times on yours, but get down there where you can see where Minnetonka's population finally gets over 100,000. Is it possible that our growth rate won't stay the same? Of course. This is just your best estimate. Year 2049. All right. Are there some things that shrink over time? Yes. Well, there's populations of towns that aren't as popular anymore. Like Detroit used to have a much bigger population, but they stopped making as many cars there, and that was one of the things anyway that caused their population to go down a lot. Anyway, there's other things that are like the value of things that go down over time. I want you to think for a minute. What do you think goes up over time, and what do you think goes down over time? Prices of houses. This is never a guarantee, but generally speaking, do they go up or down? Up. Is there exceptions to the rule? Of course, there's always exceptions, okay? But house prices generally go up over time. I experienced that in my life. I bought my house for about $111,000. It's probably worth about $300,000 now, so it's about 3 times as much as when I bought it. Okay, a lot of people that happens. But if you happen to buy it just the wrong time, which is about in 2006, the houses started, they kind of peaked right there, and then they started to go down for a while. So if you happen to buy your house in 2006, it might actually be worth less now than it was before because it went down for a while. But then over the last few years, it's been going back up again. So, you know, usually, it used to be, we never even talked about house prices going down because they almost never did. It was only in 2006, that was the first time for a long time that house prices went down significantly. Other than in real estate markets like California that go up really high and then they sometimes swing back down again, those were always more volatile. But here in Minnesota, we pretty much always, house prices just went up a little bit. Maybe they'd stall, you know, maybe go down 1% or something. But they never had a big crash until 2006. All right, how about cars? Up or down? Down. And if some of you are like, I've seen old cars that are worth a lot. Those are the exceptions. Those are if you got a really sweet like really nice Corvette, and you kept it in perfect condition, and almost didn't drive the thing, like really low miles. But a normal car, it's going to go down. A typical scenario, you buy a car for like 20 grand. 4 or 5 years later, it's worth like 5 grand. So it's gone down 15,000 in value. Okay. Now you can use your knowledge of math to your advantage on something like that. If you don't want to have the value of your car drop so much, you can do this. Is that exponential growth or decay? Decay. That's a car. You get in the first couple of years, it's going down a lot at the beginning. It's pretty steep. But do you get if you buy a car that's already quite a few years old, it's already gone down in price a lot. I'll give you an example. I bought a Lexus that brand new would cost $40,000. I did not buy it new. I bought it used for $4,500. You can look on Craigslist, and 5 minutes from now, I could find you like 50 Lexus for under $5,000. Okay, they're old, but Lexus are also known to be really good cars that last a long time. So I bought it for $4,500, and yes, I have had to have a few repairs because on an older car you have to fix it when it breaks, right? So that's a downside. But if I were to sell it today, it's gone down, but not that much. See, it's only gone down a little bit. It's probably still, I could probably still get $3,000 for it. So how much did I lose? $1,500, but that's over 5 years. Do you get at the beginning? This thing might go down 5 grand just in the first year. So it's just a different way to do it. You got to drive an older car to do that, and you have more risk of repairs. But and it all depends on where you are in life. Some people have enough money where I don't care if it goes down $5,000. I got plenty, so I'm going to buy new cars. But just you have to at least know and be smart about that. It's going to go down, especially in that first year. It depreciates a lot. All right, so this is another typical example. We have one in our homework here. Let's arrow down to the one about the car right here. A car loses 1/8 of its value each year. Now notice we weren't nice and we didn't say it goes down 5% per year. But we told you how you could figure out what percent it goes down. Use your calculator and figure out what percent that is. Well, I hope you figured out that that meant this, which meant this, which meant that it was going down what percent? 12.5%. Then I hope you know, in a real world problem, unless they give you the year, U sub 0 is the way to go. I know some of you put U sub 1, but don't. Go fix it right now. Because that's the new thing for today. If you're doing a real world problem, when I ask like 3 years from now, you want that to be U sub 3. You get what I'm saying? U sub 0 is where you'd start. U sub 1 is after 1 year, how much is your car worth? See what I mean? So it works so much better to start with U sub 0 on a real world problem. All right, then we need U sub n equals U sub n minus 1. And then we need that decay rate thing, 1 minus 0.125. Could you lump that all together and say 0.8? What is it, 875? Yes, you could, but you don't have to. I like if you put it in this way right here. You're going to see that as we move into the more complicated equations, they all have 1 plus or 1 minus embedded in them. Okay, and then yes, there's a little domain, but we really don't need this because your calculator doesn't need it, so I'm kind of minimizing the importance of that. All right, so let's get that in your calculator and then go down, and don't forget, if you were just a minute ago had your calculator set to go to the table settings out in the 2018, you're going to need to go back to 0 again. So there's going to be a lot of going to the table settings and changing them. If your first number is 0, then you should change your table settings to start at 0. Okay? All right, put that in, find out the value in 6 years, compare it with the kid next to you. If you're having issues, please ask them first, And ask me second if you're both struggling. I'll pause while you try that. Okay, so what did you get for after you went out 6 years? Have you compared with the other kid yet? If you haven't yet, check with them. Yours might be still doing 2018. Did you do the table settings? Okay. I'll pause for a sec. Okay, for those that need help putting this in, you would have started with 0 here. And then we have a decay rate, so it's 1 minus. Make sure you changed yours to minus, otherwise your value of your car is growing by accident. 0.125. And then you should have had a 23,999 to start. And then you go to table. But first I'm going to go to table settings because I'm smart enough to know I was going to start my table at 2,000 something. I don't want that. I want to start it at 1. I could have said 0. And I'm going to go to table. And in fact, I am going to go arrow up 1 just to see 0 to make sure I started right. See, in year 0, it's 23,999. In 6 years, if you start with u sub 0, you can trust these. It's the 6, just like you'd expect. So it's 10,771. That is a typical number. That's, you bought it for 24, and now it's only worth 10. It's just, you get to buy these cool things as an adult, but you also have to deal with how it goes down. You don't get to, I wish you could just buy a car and it would just hold its value and stay the same, and you could sell it for the same thing you bought it for. It'd be awesome. But unless you are a genius about buying them at the perfect time, you actually could probably do it. Did you know that cars sell way better in the spring? And in the winter, they don't sell for nearly as much. If you were really, really smart about it, you could buy cars in the winter when their prices are depressed and actually sell them in the spring when they've gone up in value. You could actually make money on your cars. But there's a little issue with that. You got to pay sales tax every time you buy a car. And so, when you buy a $10,000 car, you're talking about $700 in sales tax. State of Minnesota gets their tax so that they can, pave the roads and pay the teachers and that kind of stuff. So anyway, all right. So hopefully I've shown you how you can use this to solve real world problems. I'm going to cut your worksheet down a lot because I don't feel like I could do that much if I were you. So I'm going to cut your worksheet down a bit here. Everybody open the worksheet, and I will show you which problems I would recommend you do. Okay, here's the worksheet. And the first few are pretty tame. It just is asking you to think about, here's an equation, what would this mean? If it's talking about a bouncing ball, then what is a start of a bouncing ball? It probably is how high the ball was when it started. It must be if the bounce is what it's all about, it has to be a height. So I'd say, give the real world meanings for the number 100. It's the start. Well, we know it's the start because it's u sub 0, right? Start height. And then how about the 0.20? Well, you got to know if it's growing or shrinking, and it's got a negative there. In the context of bouncing, doesn't it make sense? Because it's going to be a little lower, a little lower, a little lower, a little lower, right? Unless it's Flubber, if you ever saw that movie. Yeah, the idea was this stuff that would go faster and faster or higher and higher every time it bounced. It's kind of a fun movie. All right, so this next one, number 2. Suppose the recursive formula, blah, blah, blah. This is about having some money, $250,000. And they're going to make it, I can see a plus here, grow by 2.5%. And they're going to ask you, basically, what does it mean to have this in the formula? And I just said it a second ago. That's how much it's growing by. All right. So this first few are just telling you to understand we're in word problems now, and what do these numbers mean in the context of the word problem. Then number 3 is your first normal one where they ask you to write an equation for this, but it's not growing by 2%. It's growing by a flat 900 every year. That changes it from geometric to arithmetic. So don't forget those arithmetic kinds still exist. You just add 900 instead of timesing by 1.2 or whatever. You just have to add 900 in your formula. All right, now we get to this question, and this is the one I really wanted to talk over with you, number 4. So everybody look at number 4 with me. Because in the past, we'd always just given you these numbers. Like, you started with 2,000, and then it went up to this, and up to that, and up to this. And we have these extra numbers here. What the heck is that for? Hint, it has to do with u. What do you think the 0, 1, 2, and 3 mean? U sub 0, U sub 1. You see what I mean? They're just telling you your info in a different way than they normally do. So if they say U sub 0 is 2,000, by putting it in a chart like this, that means you should start with 2,000. And so you'd write your little formula and say U sub 0 equals 2,000. And then U sub n minus 1. And then, is this growing? Yeah. How much is it growing by? You have to figure it out. It's that whole second one and the first one. And you figure out whether you subtract them or divide them. Your job to know what to do with these two numbers. All right. So finish number 4. I'm just going to ask you to do one more problem because I think it's a great real world problem about cars. You're all going to eventually have one. If some of you probably even already have one. It's good to know about how they grow or decay in value. So do number 5. And I'm going to say after that, I don't think there's anything new introduced. So if you do up through number 5, that's good enough. And if you look at the worksheet, you'll see this cutting out a lot of problems. Go ahead. So if you want to do more problems for practice because you realize you need them, I'm not stopping you, but I'm only requiring up through number 5. All right. Now what's next? Tomorrow? What do you think we do tomorrow? Review, sorry. Review day. And then the test is Monday. I really wish we could have a Friday test, but then we did simply have 0 time for review, which would be a little dangerous. Some people might not do so well on tests if we took it tomorrow. I mean, you have learned everything you'd need, but it won't hurt to have a review day. And then test is Monday. Okay, that's all I got for you for today.